Hi everyone, so the given problem is we have to find the minimum number of operations, and the operations are either plus 1 or minus 1, so that the given sequence will be an increasing sequence. So the definition for the increasing sequence is the previous element can be less than or equal to the next element. So let's see how to approach this problem. So to make given sequence increasing sequence, first thing to note here is that the list elements will take one of the values already present in the given list. For example, either 3 will become 2, or 2 will become minus 1, or the other way around, minus 1 will become 2, or 2 will become 3. We have to do it like this because if any number of the list becomes a new number, then we are wasting an operation. For example, if you make 2 to 4, we have to make one extra addition, so that if 2 will become 3, we have to make 3 to 4 as well. So it is costing one more plus 1 operation here. So we just have to check going to which element is cheaper for all the elements. So next we'll see how to approach this problem. Here I'll use dynamic programming to solve this problem. So I have created one more list, which is B, which is nothing but the solid elements of A. Now I have created one table by using which I'll solve this problem. So the horizontally I have taken B and vertically I have taken A. So the first element of A is 3 and the first element of B is minus 1. So to move 3 to minus 1, how many operations I have to do? 4, right? It's simple for this case. Now if I want to move 3 to 2, and I have to find the minimum operations, so I have to see whether moving 3 to minus 1 was minimum or 3 to 2 was minimum. So 3 to minus 1 was 4, the number of operations, and the number of operations for moving 3 to 2 is 3 minus 2 is 1. So the minimum of them will be obviously 1. So for the next element, for B, we want to do the same thing. Moving 3 to 2 is going to cost me 1 operation, and previously I had 1, so the minimum of them will be 1. So now moving 3 to 3 is going to cost me nothing, 0, and the previously operation I had was 1, so the minimum will be 0. And moving 3 to 11 is going to cost me 8 operations, and previously I had minimum 0, so the minimum of them will be 0. Now let's look at the second row. For the second row, we have moved previously 3 to minus 1, which costs us 4 operations. Now we'll move 2 to minus 1 as well. So the total operation is going to be 4 plus 2 minus of minus 1, which is 3. So total operation will be 7. So now let's look at this note. So to find this element, what we have to do is we'll either remain where we were, that is 7, which is Dij minus 1. We either remain at here, or we move 3 to 2 and we keep 2 as 2. That is, we move Ai minus 1 to Bi, that is 3 to 2, and we move Ai to Bi, that is we remain where 2 were, which is 2. So that one will be, and we want to find the minimum of it, so this one is we'll remain where we were, which is 7, or we'll move 3 to 2, which is this number, which we have already found out from the table, 1, and we move this Ai to Bi, which we can easily find by subtracting these two, which is 0. So the minimum is gonna be 1 here, so put 1. Again we're gonna follow the same thing for the rest of the elements. So we either remain at 1 or we move 3 to 2 and 2 to 2. So now the value we'll get is we'll either remain at 1 or we'll move 3 to 2, which is going to cost us 1 operation, plus 2 to 2 is 0, which is 1. For the again the next thing as well, either we're gonna remain at where we were, which is this 1, or we're gonna move 3 to 3 and we're gonna move 2 to 3, which is nothing but the absolute value of ai minus bj. So which is 2 minus 3, which is minus 1, and the absolute value is 1. So minimum is 1. And for the next element it's also gonna be 1. So now we have made 3 to minus 1, 2 to minus 1, and the total operation was 7. Now if we move minus 1 to minus 1, it's gonna cost us nothing, so we'll just write the value above, which is 7. Now for the next element to find, we want to find the minimum of, we either remain where we were, which is this 7, or we'll move 2 to 2. So the cost previously was this one, 1 plus or minus 1 to 2. So minus 1 to 2 gonna give us 3. So the minimum of them here is 4. So we'll write 4 here. So either we're gonna for the next element, either we're gonna remain at 4 or we're gonna move 2 to 2, 1, which is this one, plus we're gonna move minus 1 to 2 again, so which is 3. So minimum is 4. Again we're gonna follow this same rule. Either we're gonna remain at where we were, which is this 4, or we're gonna move the previous element to the current element 2 to 3. The cost of it was this 1, plus we're gonna move minus 1 to 3 as well. So minus 1 to 3 is gonna cost us 4 operations. So the minimum will be 4. For the next element, either we're gonna remain at where we were, or we're gonna move 2 to 11. So previously the previous minimum was 1. For that previous minimum was 1 plus minus 1 to 11, which is gonna be 12. So minimum is 4. So for the next row, we're gonna move 2 to the minus as well along with that previous operations. So 2 to minus 1 will be 3 operations. So 7 plus 3 here will be 10. So we for the next element, we either remain where we were, which is 10, or we'll take the previous minimum, which is 4, plus the current value of moving this 2 to 2, which is 0. So the minimum here is 4. So we'll put 4. For the rest of the element as well, we'll either remain where we were, which is 4, or we'll use the previous minimum plus moving this 2 to the 2, which is 0. It's again gonna give us 4. Now for the next element, either we're gonna remain where we were, which is this one, 4, or we're going to take the previous minimum operation, which is 4, plus the current operation of moving 2 to this 3, which is 1. The minimum is 4. And for next one as well, we're gonna get 4 here. So now let's look at the last row. So making 5 to minus 1, we'll add sorry, not 5. Here we have 11. So to make 11 to go to minus 1, we have to do 12 operations. So we'll add it here to 10, which will be 22. And to find the next element, we'll either remain at where we were, which is 22, or we'll take the previous minimum operation, which is here 4, and moving this 11 to 2, which is 9 operation. So minimum of them will be 13. So now either we'll remain at where we were for the next element, 13, or we'll take the previous minimum operations value plus we'll move 11 to 2, which is 9, so 13. Let's see the next element, minimum of, either we're gonna remain at where we were, or this one, or take the previous minimum operation 4 plus see how much operation do we need to move 11 to 3. It's gonna be 8 here. So the minimum of them is 12. So let's see the final element. So either we're gonna remain at where we were, which is this one, 12, or we're gonna take the minimum operation as above, which is 4 plus moving this 11 to 11, which is 0, so it's 4. So the final answer will be this value, which we'll get at the end of the table, which is 4. So the minimum operation to make this A to be an increasing sequence, we have to do 4 operations. So here you can find it as well, that we can make 3 to 2 and will remain 2, so it's gonna cost us 1 operation. Will remain 2 where it is, no operation will be required here. We'll make minus 2 to 1, so 3 operations gonna be required here. So the sequence gonna be 2 2 2 2 and 11 at the end, and the operations, total operation will be 4. Total minimum operation will be 4. If you want to look at the code, here it is. Here I've sorted the given sequence, and here I'm, instead of creating the table, I'm only creating the list because it'll be more memory efficient, and as we have seen, we only require the last value, so we don't need to save these previous values in the table, so it can be memory efficient. So here is that table traversal, and here is that given conditions that we have to take in order to find that minimum operation. So at the end of it, we'll return that last value of the list or the table. That's it. Thank you.